unfortunately. So obviously before we start, talk about what automated testing is. So automated testing is basically a way of teaching the computer to tell you whether or not your code is working. This is a very relevant thing for us because as we're software developers, we can make sure that whenever we ship a product that it works the way we expect it to. So what this means is basically specifying a set of inputs and then making sure that the program can check the behavior of our program the way we expect it to be. So why do you need this? Why do you need automated testing? The primary reason is that it helps you answer these three questions. The first one is, how do you know that your code works? It seems like kind of a trivial question, but the reality is, a lot of people, when you submit your marks, are like, hey, we'll see if it works or not. In the real world, you can't just throw it out into the public and say, okay, don't file bug reports, it'll be okay.
Be surprised.
In general, it's probably not the best software development practice. So, the idea is that by developing a set of test inputs and describing the behavior that's supposed to happen when you execute them, you're describing the behavior of your program and making sure that it does what you want it to. And by running these tests and demonstrating that in all these scenarios it works, you're showing that your code works properly. This is probably especially useful if you go to a work term and your employer asks you, okay, and does this work? The second question, which is the obvious corollary to the first one, is how do you know something is broken? The question and answer to that is you find a test case where it doesn't break, where it breaks. So, if you can figure out an input where it doesn't have the behavior you want, you know something is broken. That's not very useful on its own, but it's very useful when it comes to the last question. The last question is, how do you make sure it never breaks again? So this problem may not seem evident to you at the moment when you're working on your own little projects or working on CS assignments, because you know everything you've done up till finishing the assignment. But as soon as you introduce another developer, if you want a piece of functionality to work from the point where you release it to every iteration after that, you have to make sure that there's tests for it. This way, whenever I'm a developer working on someone else's project, whenever I make a change to the code, I run all the existing tests and make sure I haven't broken anything. This means that if any flaw is found in a program, it is never reintroduced. This is known as regression testing. So, I'm going to talk about automated test systems and how you build a simple one and pre-existing ones. So the three primary tasks an automated test system has is to run, verify, and report. So running is basically, for a set of test cases, it needs to take those and pass them to your program. In the case of all of our CS assignments, that's simply been passing input to standard input. But in much more complex examples, this can mean doing network requests to web servers. This can mean clicking specific buttons in specific orders. It can mean changing the system time to figure out what happens in certain scenarios. Basically, it needs to figure out a way of, given a certain set of test input, how to make the program acceptable. The second step, which is the most useful one, is verifying. So the system of verification means that just because it's run them, I need to know whether the output is correct. So there's various ways of doing this. In our CS assignments, we've seen two different ways of doing this, which I'll talk about both of. One of them is if we have a working piece of code that we know outputs the correct thing, then we simply compare the results of our version and the working version. Now, this seems kind of strange because you'd expect that if I have a version of working code, why do I write my own? But there are arguments to do this. One of those reasons is optimization. If I have a piece of code I know works, but it's very slow, I can get the desired output and I know that's correct. Then I can run my optimized version and see if that outputs the same thing. If it does, then the optimization is both running faster and giving the correct output. The last step is also very helpful, and it is reporting. So reporting is that once the system has verified whether or not whether the answer for the specific input case is correct, you need some way of giving the developer some notice saying that this is working or it's not. In those basic case, all it says is test pass, test fail. As you improve the reporting system for an automated test system, there will be more and more information to help you track down the bugs. The goal of the system is to make sure that your code is working, and then if it's not, to identify the problem as quickly as possible. So to demonstrate some of these things, I'm going to jot down the console. So, for the purposes of demonstration, all of these examples are going to be talking about the assembler we wrote for 6041 problem 3 and 4. Sorry, assignments 3 and 4. So, in the most basic case, we'll be doing manual input, manual verification, and then no reporting. So, in the most naive way of doing this, all I'm doing is run my assembler and then give it input. Now, ignore that. That's not particularly helpful right now because I can't see any output at all because it's outputting binary. So the very first thing I can do is pipe into something that's a little more useful. So I'll pipe it to XXD, which will dump out the contents in more useful format. passes and flags. So the dash B just set the output to binary, so it'll give me every single bit, and the dash C4 is grouping 4 octets, so I'm going to get 1 byte per line. So now I type something like this. I now get the exact bit output for that command. Now the program is outputting. So this is now slightly better, but this is still manual input, it's still manual verification, it's still reporting. If I wanted to know that's right, I have to pull up the MIPS reference sheet and figure out whether that perfectly corresponds to what I typed in. This is very annoying, time-consuming, and frankly not very effective. So the very first thing we can do is take away the manual input. If we're going to be testing the same thing over and over again until it works, it makes absolutely no sense to type it in every single time. So the very first thing we want to do is store a test case of input. So the way you do that is I'm going to make a test file, test input file. So I'll load it into register. Okay, so now we can get automated input. Sorry, console's acting up. Okay, so now when it comes to the file, I now have a dump of what my thing compiles to for that specific input case. And this is useful because now instead of typing every time, I can just do this. As many times as I want, and it's much, much faster. So by having a test system that will work like this, or incrementally better like this, means that we can test the program faster. Less time testing means more time developing, means you can get your product out the door faster. However, in this case, I'm actually going to increase the font size a little just so I can get more characters per line. Can everyone still see this fine? Yeah? Okay. So the next step is we need some way of automatically verifying that our output is correct. So what we do here is we take the test input, then pipe it to some output, and we were lucky, for this time we were given a utility we know works, which we should be basically writing the same equivalent of. So that utility in this case was stage241 finasm. That's an in test.finasm.out. So now we have 2 copies. So if you look at we have 2 different outputs. Correctly. Yeah. And if I diff these, I can now see that these files differ. So now we have automated input, we have automated verification, but we have very poor reporting right now. Because the fact that they differ just means that my code isn't working. It doesn't tell me at all why or where it's not working. So just to make this code a little bit shorter for testing, Nico pointed out on his group that you can actually pass subshells to diff. That looks like something like this. Yeah, it's just because the console grabs.
Yeah, if you hit reset,
there you go. So this is the command that will tell me whether they differ or not. So in one command, I'm now running my code and the control for a specific set of input and seeing whether the output is the same. Now again, this solves the problem of we know it's broken, but we don't know why. So the way we improve this system, and hopefully this will fit on one screen, is we pipe both of them to XXD. Nope. Okay. Alright, who's going to cooperate? Okay.
Control L to resolve the line.
Okay, I'll add the command indent then. So the way I do this is I can pass it both of them parameters that will give me a more real output. And the reason this works is if both our inputs are the same, then both our outputs in XXD will be the same. So now you'll see that we have a little more useful output. You see that the one on the top is the control, or sorry, the one on the top is our output. So this is what our code is outputting, and this is the control. So now we have a little bit better idea of what's going on. We know that specifically this bit is being set and it's doing not supposed to be. So this is still not an ideal format figure out what's going on, what's going wrong. And the problem with this is that, yes, we have